ሃይ ሰላም ናችሁ ሁሉ ሰላም በዛሬው ዕለት ደግሞ እንዴት ከግራፍ ላይ ግራፍን ማንበብ እንዴት እንደምንችል እናያለን ያው የቬሎሲቲ ታይም ግራፍ የዲስታንስ ታይም ግራፍ ባለፈው አይተናል ከቬሎሲቲ ታይም ግራፍ እና ዲስታንስ ታይም ግራፍ እንዴት ሌሎች ነገሮችን ማግኘት እንችላለን ለምሳሌ ከቬሎሲቲ ታይም ግራፍ እንዴት ዲስታንስ ማግኘት እንችላለን ከዲስታንስ ታይም ግራፍ ደግሞ እንዴት ቬሎሲቲ ማግኘት እንችላለን የሚሉ ሁለት የአንደር ዩኒፎርም ሞሽን እንዴት እንደምናይ አሳያችኋለሁ ማለት ነው so from a graph you can read or get additional quantity that means one if you are given a velocity time graph here you can get distance from it two if you are given a distance time graph, you can get velocity from it. Now, how this is possible? Let's say, how is this possible? How is this possible? That possible? Yes. One, let's say, to get a distance, we say that distance can be get from velocity time graph. That means to get distance from velocity time graph, find the area. One, find the area of the given graph. Therefore, let's say one to get distance from velocity time graph. Find the area of the figure between the graph and the time axis. The area of the figure formed by velocity time graph and time axis equal to the distance traveled. That means from velocity time graph, when we get the distance, that distance is simply the area that formed by the velocity time graph. For example, let's see an example. The velocity time graph of a bus is given below. What is the distance? The distance of traveled by the bus A during 3 seconds, B during 6 seconds. We have the figure or the graph of velocity time graph is given or looks like this here. This is velocity in meter per second. This is time in second. Let's say this is 1, 2, 3, and let's say 4. This is that means it is because we are looking for uniform motion. Therefore, this is let's say 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 during 3 seconds. 1, 2, 3, 4 here, and because it says what the velocity time graph of a bus is given below. What is the distance of traveled by the bus during 3 seconds and during 6 seconds? During 3 seconds means during 3 seconds, the first 3 seconds is this one. Let's say let us shade this one. Shade this one. That means this is the rectangle in 3 seconds. This is rectangle in 3 seconds. The large one is the large one. This one is rectangle in the rectangle in 6 seconds. In 6 seconds. Therefore, you know how to find the area of the rectangle. It is the base multiplied by the height. What is the base of this rectangle? The first 3 seconds. What is the base of this rectangle? It is what? 3. It is 3. What is the height of the rectangle? It is 4. It is 4. That is what? 12. 12 meter per second. 12 meter, because this one is in second, this one is in meter per second, second by second. Therefore it is 12 meter. It is 12 meter. This is the distance traveled by the bus in 3 seconds. The distance traveled by the bus in 3 seconds. For 6 seconds, you take the larger rectangle. That is the rectangle in 6 seconds. This one. This time, the base of the rectangle becomes what? 6 seconds. The base now area is equals to base times the height. In this case, the base is 6 seconds. 6 seconds, but the height is the same. That is what? 4 meter per second. 4 meter per second. Now, if you multiply, you get what? 24 meter. This is the distance traveled by the bus in 6 seconds. In 6 seconds from the graph. That means we get distance from velocity time graph. Therefore, the area under velocity time graph is distance, or speed time graph. You can say the area under speed time graph is a distance. The area under acceleration time graph is velocity. Now let's see how to get velocity from distance time graph. Let's say Roman number 2. To get velocity from distance time graph, we have to find the slope. Find the slope of the graph. Do you know how to get the slope of the graph? The slope of a graph is equal to the vertical increase of the graph divided by the horizontal increase of the graph. This is always true. The slope of the distance time graph is equal to velocity. Therefore, the slope of the distance time graph is equal to velocity or speed. Let's see example. For example, the distance time graph for the car. The car is given below. What is the velocity the velocity of the car from the graph okay. The graph looks like this. The graph looks like this. Here distance in meter, here time in second. Let's say this is 4, 8, 12, 60, 20 and 24. 1, 2, 3, 4, 5, 6. 6. This the graph. Let's say this one the graph. For the accurate of the graph. So let's say here is 6. Let's say this is 6 with 24. Okay, for each graph, let's say for 1 and 4, the value of time is 1, the distance is 4. Therefore it looks like this, the graph. 24 for 5, 20 for 5, 60 for 4, 12 for 3, 8 for 2, 1 for 4. Okay, this means here we do have, in this case, we have vertical increase, the vertical increase. For this one we have horizontal increase. Okay, to get the velocity from the distance time graph given above, you have to find the slope of the graph. To get the slope of the graph, first take any 2 points on the graph. Let's take this point, or take this point. Okay, we can take any 2 points. Let's take for example 1 with 4 and 6 with 24. The first coordinate, this one, the first coordinate here, the first intercept or coordinate, that means 1 and 6, tells you about the time. It tells about what? Time. It tells about time. The second coordinate, 4 and 24, are a distance traveled. It tells about the distance. Then the slope of the graph is equal to, now the slope is the vertical increase over horizontal increase. That means the slope of any slope is equal to the vertical increase of the graph divided by the horizontal increase. This means the vertical increase is increased from what? From 24, or the increase is 24 to 4. That means 24 minus 4 over 6 minus 1. This is 20 over 5 is equals to 4 meter per second. Therefore, the slope tells us the velocity, because we say that from distance time graph we can get velocity. This velocity is calculated as what? By using the equation of the slope. Now, in general, from distance time graph, we can calculate a velocity. Velocity means a distance time graph. Therefore, here from distance time graph we can get velocity or speed. From velocity or speed time graph we can get distance. In this case, using what? Using slope, the equation of slope. In this case, using area, the area. Therefore, the area under velocity time graph is distance. The slope of distance time graph is velocity. That means the slope of velocity time graph is acceleration. The slope of velocity time graph is acceleration. So this is simply how to read the graph under the uniform motion from both distance time graph and velocity time graph. አጠቃላይ ይሄንን ይመስላል እንዴት ማግኘት እንደምንችል ከዲስታንስ ታይም ግራፍ ቬሎሲቲ ማንበብ እንዴት እንደምንችል ቬሎሲቲ ታይም ግራፍ ላይ ደግሞ ዲስታንስን እንዴት ማግኘት እንደምንችል በተለያዩ ሁለት ፎርሙላዎች አይተናል ለዛሬው ይሄኛው ይበቃናል በሚቀጥለው ቪዲዮ እስክንገናኝ መልካም ጊዜ